Okay po.
So go ahead, sir.
Yes po. Good morning po, sir. Good morning, classmates. I'm presenting my topic for today po for the modular design, coupling, and cohesion. A brief introduction lang po. I am Marlo Pigo, currently working in Lyceum of Alabang in the IT department po. I have my fair share po of experience po with project management as well as um, programmer system development po. Pero I'm more focused po on managing po different services po of the department. So anyway po, I created this presentation po. I made it very simple, very short for for convenience and easy understanding po. So again po, my topic po for today. Sorry po, I apologize po. No? I think I'm coming up with a cold po. No? So my topic po for today is number 1, modular design, number 2, coupling, and number 3, cohesion. So for modular design, so what is modular design? Modular design or modular programming is a process that involves splitting a computer program into individual subprograms. Those subprograms can be referred to as a module. A module is an individual component which can be utilized with a number of function and application in combination with other components in a system. To better understand the definition, here's an example. So a program can be developed more quickly with a modular approach since small subprograms are easier to understand, design, and test than large programs given that module inputs and outputs are well defined. So for our example, we have here our broad program, which is the fixed car. So on the first level, we try to uh, divide the programs into smaller subprograms such as take car to the garage, prod things with a hammer, and paying the mechanic. Then on the second level, we further try to subdivide the program into smaller subprograms or a module. For the take car to the garage, we can divide it into module A and B, which is start car, and drive it there. In prod things with the hammer, we can further divide it into get hammer and prod things. And in the pay money, we can further divide it into get wallet and give cash. So basically, what we did here, we try to make the program smaller, much simpler, for easy understanding, designing, and for testing. Kasi po, for example, the fixed car, when you think fixed car, probably hindi lang po isa, dalawa, or tatlo po yung process na naiisip po natin when you say fixed car. No? So, long story short po, we try to divide the big program into smaller ones for convenience po. As modules get smaller, debugging becomes easier, so less code to have problems with. Modules are easier to update because we know how to separate parts of the program relate to each other. We can reduce errors by ensuring they don't interfere with each other. And if there is a need to change the code for whatever reason, then there is a lot less to worry about. So let's try to imagine lang po, no, in module A and module B, let's just say na dalawang magkaibang subprogram po sila or dalawang separate na module. Given that well-defined po yung inputs and outputs po nila, if you try to change something in module A, it will not directly affect module B. So meaning po, yung error po natin would not cause a domino effect if, for example, in-update po natin si module A. In a modular design, everything is self-contained. Therefore, development of modules can be assigned to different programmers according to their skill or expertise. So let's say po na yung ating pong project or ating pong program can be divided into 6 modules, and let's just say that you have 6 personnels or 6 programmers on your team. You can divide po each module, or you can assign each module to an individual programmer. Another thing to consider, let's just assume that among po dito sa modules A to F po natin, let's assume lang po kunyari na si module A, which is yung start card po natin, is yung pinaka-complex na module sa kanilang lahat. We have the freedom po no, to assign this particular module to a particular programmer po with the higher or with the uh, higher or expertise similar po in this program po no. So meaning po you can assign simpler modules to a more um what you say newer programmer, and then yung harder modules po you can assign it to a more senior programmer given that they have more experience po no, in development. If if a need arises to code a module in a different programming language, normally yung reason for that po is for efficiency purposes. A shorter code will be easier to translate. So, if for example po, you want your application po to run on a different platform, instead of recoding everything on another programming language, you can just pick na particular module that will run on that platform only, para po yung module na yun lang po yung ating i-recode to a different programming language. So it makes our job easier po no, to make the program much more flexible po and deployable. Another advantage of a modular design is that each module can be reused in different parts of the program or be used by a different program altogether. Example, if you want to create a module for deliver car to owner, so take note po, currently I have take car to garage, prod things with the hammer, and pay money. So yung deliver car to owner is a different module po. You can reuse the start car and drive it there. So, eto po module A and module B po natin, we can use that po to develop the deliver car to owner. You can use start car and drive it there provided that you change the value of location from garage to owner's home. Okay? So, ang difference lang po with subprogram of take car to the garage and deliver the car to the owner is yung location po in which na saan dadalhin po yung vehicle na. Pero we can reuse po the same module A and B to do that. So to have a better understanding of modular design, we will be talking about methods as it's a great way to encapsulate certain parts of the program. In methods, a method declaration is comprised of the functions header. This consists of the following. So number one, we have a modifier. It can be public, protected, private, or static. It restricts the access of a class, constructor, data member, and method in another class. Number two, a return type, a particular data type or void. This causes the program control to transfer back to the caller of a method. Number three, a function name. Number four, parameters that function takes in parentheses. Take note that variables received by a method or in its definition are called parameters. Take note that variables passed into a method when it is being called are known as arguments. In Java, methods may operate in of 4 ways. So number one, we have no parameter and no return value. Number two, we have no parameter and a return value. Number three, parameter and no return value. And number four, a parameter and a return value. So To further elaborate the modular design, I have here po an simple program example po of a main menu. Confirm ko lang po, kita po sa screen po natin yung Eclipse po.
Yes, sir.
Okay po. So I have a simple program po here, implemented a line para makita po natin yung divisions po ng program natin. So we can say that these divisions are, we can say, modules po of this particular program. So on the first part, by the way, before ko po i-discuss yung sa left side, let me run the program po muna. So here po, when you run the program, it will display welcome and a main menu with a selection of items 1, 2, 3, and then Q for quit. So for example, let me enter 1, it's going to do task 1, and then it's going to redisplay the main menu. When I press 2, it will do task 2, and then redisplay the main menu. And I press 3, it will do task 3, and redisplay main menu. If I press, okay, let me rerun the program. If I press 4, it will specify invalid input. And then when I press Q, it will exit into main menu. So our program is divided into three division or three modules. First module wherein it's our main method. We all know that the main method is the first thing that the program runs. So in our main method, it just outputs the welcome message and calls method main menu. In our main menu, it comprises of a loop, a printout for the menu, uh, input, which it called the input method, which is the third part, and converted it to lowercase. And then the third part is a switch to identify what instruction it's going to execute based from the input we got from the method input. So here in our main method is just a loop that will ask the input method for a input, and then based from that input, it's going to run on this condition where it's going to identify the first character where the method input got its value. So if the user po types 1, 2, or 3, it's going to print out accordingly do task 1, do task 2, do task 3. If the user type Q, it's going to exit the main menu. And if in case the user entered a value that is not does not meet in these four cases, it's going to print out default invalid input. So in modular design, we can say po na what we did here, we created a module, a separate module for the main menu display. We created another module for the input. So if for example po lalapad or mag-upgrade po tayo ng program, probably you're going to ask the user several inputs po. No? So meaning this input method can be reused in the other parts of the program instead of recoding or pasting po codes continuously dito po sa area po na ito. So tinatawag lang po natin ang tinatawag si method input. So in that way, nare-reuse po yung program, and at the same time, kapag po nagmo-modify tayo, hindi po naapektuhan yung main menu method po natin. Next, we have coupling. So coupling refers to the degree of direct knowledge that one element has of another. In other words, how often do changes in class A force related changes in class B? There are two types of coupling, which is a tight coupling In general, tight coupling means the two classes often change together. In other words, if A knows more than it should about the way in which B was implemented, then A and B are tightly coupled. In loose coupling, in simple words, loose coupling means that they are mostly independent if the only knowledge that Class A has about Class B is what Class B has exposed through its interface, then Class A and B are said to be loosely coupled. To elaborate that, I have here a sample of a tight coupling program. So suppose you have made two classes, first class called volume, so we have this one, and the other class evaluates the volume of the box, which is this one. Any changes that would be made in the volume class would be reflecting in the box class, hence both classes are independent on each other. This situation particularly is called as a tight coupling. In comparison po, I have here sample program for a loose coupling. So when an object sources, we call it loose coupling. In other words, the loose coupling means that the object are independent. A loosely coupled code reduces maintenance and effort. This was disadvantage of tight coupled code that was removed by the loosely coupled code. So if you notice po, between two programs, so program A, which is our uh, tight coupled, and program B, which is loose coupling, uh, please notice yung class box po natin. So dun sa class box po natin in loose coupling, we furthermore, instead of calling directly volume, we have another method which is get volume, which calls po yung private method natin, which is a volume. Okay? So hindi po sila directly independent with each other. Yun po yung difference natin between tight coupling and a loose coupling uh, a program. So which is better, tight coupling or loose coupling? In general, tight coupling is bad, but sorry po, most of the time, because it reduces flexibility and reusability of code. It makes changes much more difficult. It impedes testability. Loose coupling is a better choice because a loosely coupled code will help you when your application need to change or grow. If you design with a loosely coupled architecture, only a few parts of the application should be affected when requirements change. Next topic, we have cohesion. So cohesion refers all about how a single class is designed. Cohesion is object-oriented principle most closely associated with making sure that a class is designed with a single, well-focused purpose. Please take note of that. The more focused a class is, the cohesiveness of the class is more. The advantage of high cohesion is that such classes are much easier to maintain and less frequently change than classes with low cohesion. Another benefit of high cohesion is that classes with well-defined purpose tend to be more reusable than other classes. So suppose we have a class that multiply two numbers, but the same class creates pop-up windows displaying a result. Let me skip this one. I'm going to go straight to the example po. So I have here two sample programs. On the left side, I have a high cohesive class. On the right side, I have a low cohesive class. In the above image, we can see, wait lang po. We can see that a low cohesive program has only one class and is responsible to execute jobs which are not in common. So ito pong nasa right side, yung dinidescribe natin, which is a low cohesive class. While a high cohesive class, which is ito pong nasa right side natin, has two well-defined class which gives us better maintaining facility and more reusable. So kung napapansin po natin, as said po dun sa description, sa right side natin, low cohesive, not necessarily yung mga codes po natin is directly related to each other. So for example po, I have here some syntaxes for the computation, which is these 3 lines. Then I have another syntax po for printing out of the output, which is itong pong 4th line. In a high cohesive class, computation and printout po was separated po no, in mul and in class display. So yung computation po natin is here in mul, while yung pag-output po natin is here on the class display. So if for example po, somewhere in the program, we're going to reuse po, no, or kasi sa case po natin, this is very simple po, no, very direct. Pero let's assume na for example, this is a much more complicated program. If you have a generic syntax po for display, which can be reusable for different parts of the program, we can just simply call po this class. No? So between these two po, high cohesive and low cohesive, much more prone po to be reused itong high cohesive class po natin. So the difference between cohesion and coupling. So for coupling, it refers to how related or dependent two classes or modules are toward each other. For low coupled class, changing something major in one class should not affect the other. High coupling would make it difficult to change and maintain your code since classes are closely knit together. Making a change could require an entire system revamp. Simply because kasi po, each part is tightly connected with each other. So kapag nagpalit po tayo on one part, definitely it's going to affect the second part po, no? Kasi it's working, it's running as a one unit po, no? So as for cohesion, refers to what the class module can do. Low cohesion would mean that the class does a great variety of action. It is broad and focused on what it should do. And high cohesion means that the class is focused on what it should be doing. So to better have better understanding po, I have here uh, a diagram po, no. So yung cohesion, I hope kita po yung color po sa screen natin. So yung cohesion po refers to the blue line, while coupling refers to the red one. So coupling, which is the red one, is the indication of relationship between modules. It is concept of intermodule, and coupling has also many types, but usually low coupling is good for software. So when we say coupling po, no, it refers to the relationship in between two separate modules. While in cohesion is the indication of relationship within module. So take note, within module, for example here, I have here module 1, where A is in cohesion with B. It is the concept of intra-module, and cohesion has many types, but usually the cohesion is good for software. So a comparison between the two, so between cohesion and coupling, so cohesion is the concept of intramodule, while coupling is the concept of intermodule. Cohesion represents the relationship within the module, as referred to this diagram po. It's under one module. Coupling represents the relationship between modules. So as you see po again in this diagram, the coupling between module 1 and module 2. Increasing cohesion is good for software. Increasing coupling is avoided for the software. In cohesion represents the functional strength of modules. In coupling, it represents the independence among modules. In cohesion, highly cohesive gives the best software. In coupling, loose decoupling gives the best software. In Cohesion, module focuses on a single thing. In coupling, modules are connected to other modules. So, yun po, that's the last part po of my topic. I think po we're going to have more examples po later pag nag-report po si Sir Andro with regards po sa design pattern.